Hello friends, welcome to Physics Lives channel. Today we are discussing about the complex analysis 7th class. So here we studying about the contour integrations. Contour integrations in which if you are given with a contour like this z minus x plus iy, that's equal to r. So this is the general format of the contour. So r is a radius, x and y, that are the center of a circle of the contour. Okay, so if you are given with a general theme like this, general representation like this, if you are considering a contour of radius r and center x comma y. Okay, so uh, here are some examples that is given with the C such that z is equal to 5. So the radius equal to 5 and centers x and y are zeros. So center are 0 0. So 0 0 with the 5 radius 0 0. Okay. So this is the concept. And if you are given with a if you are given with some curve that is C such that z plus 2 equal to 3. So here z minus of x plus y, this is the general concept. Okay, so if you are thinking with this, so you are considering the center as minus 2 comma 0 and 3 is the radius. Okay, so this is the general representation of a contour. So how to evaluate closed integral contour integration of this contour integration of a function f of z dz. So for that contour integration we have to find the singular point. Singular point, we have to do singular point and we have to check whether it is inside or outside. Inside or outside. First you have to find the singular point of the function and find it is inside or outside the contour, and if the residue only inside, find the residue of the singular point inside the contour. Inside contour you have to find the residue and integral closed integral f of z dz is equal to 2 pi I into summation of residue. Okay, so you have to only consider the inside singular point and to find the contour integration of the function, that is 2 pi I into summation of residue. So this is the procedure we have to do to find the contour integrations. Okay, so to find the contour integration, this is a function given with this question. You have to find a singular point. You know how to do find the singular point and check whether it is inside or outside. And it is inside, you only consider the inside singular points and you have to find the residue of that, and closed integral of f of z dz, that's equal to 2 pi I into summation of residue. And how to find it is inside or outside, so how to check? So here we are given with the some points, there is a contour that is z is equal to 3 and the points that's equal to 4i, minus 4i and 2i. We know that is a radius of 3 and you have to find the magnitude of the singular points, that's 2i, a magnitude that is equal to is less than 3, so inside, and this is minus 4i magnitude that is equal to 4, so it is greater than 3, so outside. So how to check it is inside or outside? Just find the magnitude of the singular point and check whether it is inside or outside. Okay, so this is the procedure we have to follow for to check it inside or outside singular point. Okay, so here we are considering a contour of C such that modulus of z plus 1 I minus I is equal to 5. Okay, so here we know that the general here the singular point they are given with the z is equal to 1 plus I and z is equal to 2 plus 3I. So you have to check these singular points are inside or outside. So you have to put there. So that is z is equal to 1 plus I plus 1 minus I. So that you get the I cancel 2. 2 is less than 5 now. So this is inside. So you have to just put the values of z there. Okay. So here next we have to put the values there. So here we have to do that is C such that 2 plus 3I na. So 2 plus 3I plus 1 minus I, that's equal to 5. So here 3 plus 2I. 3 plus 2I. Okay. 3 plus 2I magnitude. What is 3 plus 2I magnitude? 3 plus 2I magnitude under root 9 plus 4. So that is under root 30. Under root 13 is less than 5 na, because 5 is under root 25. So it is less than 25. So it is inside. So in this contour you have given with an expression and you have to put the singular point inside this contour and you got the value inside or outside. Okay. So you have with a contour like you are considering a C such that z plus 2 plus z minus 2 equal to 5. Okay. So this is contour and you have to check the singular point z is equal to 2I and z is equal to 5I, whether it is inside or outside. Okay, so you have to check with this. So you have to check these two. For that you have to put the value. So 2I plus 2 plus 2I minus 2 magnitude. So that is under root 4 plus 4 plus under root 4 plus 4. So root 8 plus root 8. Okay. So we got like this. So 2 into root 8. So 2 can be inside. So 4 into 8. That is 32. So which is greater than 5 now. So it is greater than 5. So it is outside. So 2I also outside and 5I also outside, because if you are given with the 5I, it is root of 25 plus 4 like that. So 2I is outside and also 5I is outside. So how to find that? If you are given with a contour, you have to put the values of z there and you check whether the magnitude is greater than radius or not. Okay. So if you are given with a contour is given and in which you have to put the values of z in contour and check with the magnitude is less than radius. If it is less, you have to find the residue, and 2 pi I into summation of a residue will give you the contour integration of the function. Okay, so this is the main idea you have to remember. Okay. So we are going to the first problem of contour integration. So if you are considering a function e raised to z plus 1 divided by z dz. So the contour is given by c such that z is equal to 1. So we know that the singular point is equal to 0 by equating denominator with the 0. So z is equal to 0. So if you put the z is equal to 0, which is less than 1, you know. So it is inside. So find the residue at z is equal to 0. So z is equal to 0 is a simple pole. So to find the residue of the function at z is equal to 0 is numerator divide by derivative denominator is 1 at z is equal to 0. E raised to 0 is equal to e raised to 0 is 1 plus 1, that's equal to 2. 2 is the residue, and to find the contour integration of the function, that's equal to 2 pi I into residue, that is 4 pi I. This is the answer. Very simple question and very good method to find the contour integration. Here other question, that is second question about contour integration, that is e raised to 2z divided by z plus pi I. This is the function contour such that z minus 1 is equal to 4. So we know that the singular point z is equal to minus pi I, and if you put in the contour, that is minus pi I minus 1 equal to 4. So this is under root pi square plus 1. So pi square, we know that pi is value is approximately equal to 3. 3 square is 9, or pi square it is approximately as 10 plus 1, that is 11, root 11, which is less than 4 now. So this is inside point. So the residue of the function, so the function e raised to 2z divided by 1 at z is equal to minus pi I. So e raised to minus 2 pi I divided by 1. So cos 2 pi minus I sin 2 pi. Cos 2 pi is equal to 1. So residue is equal to 1. So to find the function contour integration, that is 2 pi I into 1, that's equal to 2 pi I. Okay, so this is the answer for this question. Next question is about e raised to 2z divided by z plus pi I. The contour is such that z minus 2 plus z plus 2 is equal to 6. So we know that z is equal to minus pi I is the singular point. If you put the values of minus pi I, so see such that minus pi I minus 2 plus minus pi I plus 2 is equal to 6. So under root pi square plus 4 into 2 is under root pi square is 10 plus 4, that is 14 into root 14 into 2. So if you take inside the root inside in the 2 inside the root, so it is greater than 36. Okay, so that means that is it is greater than root 36 now, so which is outside the contour. Okay, so closed integral of e raised to 2z z pi I z plus pi I is equal to 0 because the residue is equal to 0. Okay, next question, this is about closed integral of tan z plus sec z dz divided by z. C such that mod z is equal to 1. So we know that at a singular point z is equal to 0. So if you put the values of z in the contour, that's equal to less than 1. So it is inside point. So find the residue. It is a simple pole. So residue of the function at z is equal to 0. The tan z plus sec z divided by derivative denominator is 1. at z is equal to 0, tan 0 0 plus sec 0 is 1, so 1 is residue. Okay, so the counter integration of f of z dz, that's equal to 2 pi I into residue, that is 1, that is equal to 2 pi I. Okay, so this is the answer for this question. So if you are considering a problem, z square minus 3z plus I divided by z minus 2I dz, C such that mod z is equal to 3 and z is equal to 2I is the singular point, and if you put the values of 2I, it is less than 3 now, so it is less than 3, so you have to find the residue of the function at z is equal to 2I, that is z square minus 3z plus I divided by derivative 1 at 2I. So z square is 2I, that is minus 4 minus 3 into 2I, 6I plus I. So minus 4 minus 5I is the answer, residue. So to contour integration of the function, that is f of z dz is equal to 2 pi I into minus 4 minus 5I. So this is the answer for this question. This is another question. You have to find the contour integration of the function log z divided by z minus 1 whole cube dz. So we know that z minus 1 whole cube equal to 0, z is equal to 1, n equal to 3. So you have to find the residue. Here the contour is such that z minus 1 is equal to half. So z is, if you put the z is equal to 1 is equal to 0 is less than half. So z is equal to 1, it is inside point. So you have to find the residue of the function at z is equal to 1. It is given by 1 by n minus 1 factorial, 1 by 2 factorial, limit z is equal to 1, n minus 1th derivative of z minus 1 all power n into f of z. F of z is log z divided by z minus 1 whole cube, that is equal to derivative of log z, that is 1 by z derivative, that's equal to minus 1 by z square, like that. So z is equal to 1, that is minus 1, so 1 by 2 minus 1 by 2, so 2 pi I into minus 1 by 2 is the minus pi I is the answer for contour integration f of z dz, that's equal to minus pi I. Okay, so next problem you have to do like this. So contour integration of cos z minus sin z divided by z plus I whole cube dz, C such that mod z is equal to 2. So z plus I whole cube is equal to 0, z is equal to minus I, n equal to 3. If z is, if you are substitute minus I modulus is less than 2, so it is inside point. So you have to find the residue for that 1 by n minus 1 factorial limits z tends to minus I, n minus 1th derivative of z minus I all power n f of z cos z minus sin z divided by z plus I whole cube. So we have to derivate this minus sin z minus cos z and double derivative, that is minus cos z plus sin z, and we have to put the values, that is minus cos minus I plus sin minus I. So cos minus I is cos China, so cos I minus sin I divided by 2 is there, so residue as minus cos I minus sin I divided by 2. So the function f of z dz integration, that's equal to 2 pi I into minus of cos I plus sin I divided by 2. So 2 to cancel, minus pi I into cos I plus sin I is the answer. So you have to find the method method, that is you have to find the singular point whether it is inside or outside, and find the value of residue inside of the values of inside, and 2 pi I into summation over residue will give you the contour integration of the function. Okay, so this is the method we have studied in this session. Thank you for watching and keep learning.